Hello everybody, a very warm welcome to the viewers of Wisdom Jobs channel. In this video, I'm going to work out some problems based on gas laws and eudiometry. So before going to these problems, I request you all to please do subscribe to our channel wisdomjobs.com because we are going to upload many more important topics in the examination point of view, and if you have not got subscribed till now, you are going to miss a lot of topics, and you please do share, subscribe and like these videos so that it's a very good encouragement for us. So with this note, I'm going to start the problems. In the last class, I have already discussed about the three important laws in the gas laws. What are they? Boyle's law, Charles' law and Avogadro's law. Now what does Boyle's law state actually? Boyle's law state that pressure of a gas is inversely proportional to its volume. Okay, and pressure of a gas is directly proportional to temperature. So this is your Boyle's law. Okay, and this is your Charles' law, and you got one more law which is volume is directly proportional to number of moles. Okay, so this is another law which is Avogadro's law, the third one. So this is Avogadro's law. Okay, now based on this we have derived the universal gas equation, which is PV is equals to nRT, where R is the universal gas constant. And of course from this, if you observe, PV upon T is equals to N into R, and R being a constant and N is the number of moles, so number of moles also you can take it as a constant. So I can write this N into R as a new constant, which is some K. Okay, so another form of universal gas equation is P1 V1 upon T1. That means these are the three. This is the first condition regarding the temperature, pressure, and volume conditions. Okay, that is equals to P2 V2 upon T2. Okay, so P2 V2 upon T2 is equals to P1 V1 upon T1 is another form of gas equation when two conditions of the gas are given to you, specified to you. Okay, so of course these all four problems or five problems which we are going to do are based on this particular equation only. Okay, now let us start with the first equation, actually the first problem. So the first problem is, what volume will be occupied by a sample of a gas at 87 degrees and 720 mm of pressure if its volume is 27 degrees centigrade and 750 ml. So pressure was 250. Okay, so he is given what volume will be occupied. That means we should determine volume. Okay, we are going to determine the volume of the gas. So here the volume, since it is to be found out, it is V2 which is to be found out. Okay, so V2 is equals to how much? Now will be occupied by a sample of a gas at 8. Yeah, so T2 is given to you as how much? T2 is equals to 87. Now whenever we are dealing with this gas equation, always you are going to convert the given temperature into absolute scale. So how to convert into absolute scale? The given centigrade plus 273. Okay, the given centigrade temperature plus 273 will give you the absolute temperature. Okay, so here for example, if I take here, it is 87 plus 273, which gives you how much? Which gives you 360 degrees. So 360 degrees Kelvin. Okay, or absolute. Next, P2 is also given to you. P2 is how much? P2 is 720 mm. So the second pressure is given to you. And coming to the first conditions, volume is, the first volume is 250 ml. Okay, and temperature is T1, which is 27 degrees plus 273, which gives you how much? 300 degrees. Okay, of course Kelvin. Next, what about pressure? P1 is 750 mm. So this is the data given to you. Okay, now with this given data, I need to determine V2. So what equation I am going to select here? I cannot select PV equal to nRT. Okay, I cannot select PV is equals to nRT because there are two conditions here. P1, V1, T1 at first temperature and second temperature are also given. So here this is only at a particular temperature T. So this equation is not suitable. So which is a suitable equation for this problem? It is P1 V1 upon T1 is equals to P2 V2 upon T2. So now obviously from this, what is V2 which we want? V2 equals to P1 V1 T2 upon T1 P2. Okay. Now let us substitute all the values. So what would be V2 from this? V2 would be P1. So P1 is 750 into V1 is 250 divided by T1. T1 is 300 into P2. P2 is 720 into T2 is 360. So let us cancel first zeros. Okay, all zeros can be cancelled first. Okay, so you are remaining with what now? So 3 into 25 times. Okay, so 72 twos and 36 ones. So it is 25 into 25 by 2 or 625 by 2. 625 by 2 would give you 312.5. Yeah, so it is 312.5 ml. Okay, so this is the answer for V2. So use this P1 V1 by T1 equal to P2 V2 by T2 equation and solve the unknown. Okay, so in this way you can solve the problems. So let us work out one more problem based on the same concept. 152 ml of a gas at STP was taken to 20 degrees and 729 mm pressure. What was the change in the volume of the gas? Okay, now let us jot down the conditions. So 152 ml of gas at STP. What is STP? Standard temperature and pressure. So V1 is given to be how much? V1 is 152 ml. Okay, next STP he mentioned, so it obviously means P2 is equals to 760 mm. Okay, and T2 would be obviously 273 degrees Kelvin. Next T2 is given to you, so T2 is equals to how much? 20 degrees centigrade. So in the previous problem I told you how to convert the given centigrade temperature to absolute, add 273 to the given temperature. So it is going to become how much? 273 plus 20, which is 293 degrees Kelvin. Okay, and P2 is going to be, sorry, actually these are all P1s. This is P1. Okay, and here also it is T1. Okay, this is P2. So P2 is how much? 729 mm. Okay, now these are the conditions given to you. So now let us use the same equation. P1 V1 by T1 is equals to P2 V2 by T2. Okay, so V1 is given to you and all the other parameters are given. So which is the parameter which should be determined? What is that parameter which is to be determined? It is V2. Okay, so now let us determine V2 from the given data. So what is V2? P1 V1 T2 by P2 T1. So it is, what is P1? P1 is 760 into 152 into T2 is 293 divided by what is P2 given? 729 into what is T1? 273. Okay, so now let us calculate this using this calculator. Yeah, you are getting it as 170. So it is 170 ml. Okay, now what is that actually he is asking? He is asking you what was the change. Okay, so what was the change in volume? So initially what was the volume actually? The initial volume was given to be 152 ml, right? So the initial volume was 152 ml. Now the final volume we got it as V2. V2 equal to 170. So change in volume is V2 minus V1. So change in volume is equals to 170 minus 152, which is 18 ml. Okay, So this is the final answer for your required volume. Okay, a change in volume. So I think you might have understood this concept of how to apply the universal gas equation for two different conditions of temperature, pressure and volume, right? So in the next video we are going to work out some more problems based on the same equation, and please be tuned to our channel wisdomjobs.com, because we are uploading so many educational videos every day, and if you have not subscribed yet, you are going to miss a lot. So please do subscribe, like and share these videos among your friends, so that more people will be useful for more people will be using these videos and they get benefited by these videos. So please do subscribe to our channel. Thank you for watching. Have a nice time.